Hello guys, I am Sajjad Mustafa from AI Sciences. Today we are going to learn feature scaling and feature normalization. Scaling and normalization both are synonyms, you can use any of these. We'll be starting with introduction of feature scaling, then we'll see why it is important, and finally we will be implementing a practical example of feature scaling using Python. If you have not if you don't know about AI sciences, we make tutorials and complete comprehensive courses for the beginners. You can check out the links in the description. We work on AI and data science related topics, so if you are looking to start your AI or data science career, you're most welcome here. So first of all, what is feature scaling? Let's see it through a practical example, a very non-technical sort of example. So let's say we have to pay 10,000 to two people, right? And one is from Europe and the other person is from USA. And these are the rates of today. As today I'm shooting this video, these are the rates of 1 euro is equal to 1.22 USD. So euro and USD both are not equal. So let's say here is a guy USA and here is another guy from Europe. So if I pay the guy from USA in dollars and I pay him, let's say $10,000, and I pay this guy from I don't know the sign of euro, let's call this the sign of euro. So I pay this guy also 10,000 euro. Is it equal? Is it equal? No, certainly it is not equal. Why? Because the scales of these two economies are not same. Euro right now, euro has more value than United States dollar. And if I talk about 10,000 euros, it equals to almost more than 12,000 USD. So what I have to do is I have to introduce some, let's call it black box. I have to introduce a black box, okay, that is called feature scaling or feature normalization, right? So this black box is we are going to learn. What this black box will do is this will scale the economies or whatever it is. Let's not call it economy, let's call it feature. So it will scale the feature so that both the guys from Europe and from USA will get equal part. Now what is this black box? How we can do that? You will learn it in a minute. So that's a simple introduction of scaling. Now what is feature? I hope we know what is feature. So let's talk about the data set that we are using today. So let's say this is the data set and all the columns, roughly speaking, not very technically speaking, all the columns we call them features, right? So let's move forward. By the way, if you have any ambiguity about feature, what is feature, you can check out our complete channel. We have complete course on feature engineering, so you can check it out. So why it is important in machine learning? So let's again talk about an example. So let's say we have two features. One is age, the other one is salary. Normally ages range from 0 to not ideally 0, but let's say 0 to 150. You won't see many people going above 100, but let's say 0 to 150. And salaries range from 20,000 to let's say 500,000. It goes, you know, below 20,000 and above 500,000 as well, but let's just for the sake of simplicity, let's call it like this. So now if you will train a model, obviously the scale of age is much lesser than the scale of salary. So impact of salary would be huge on your, let's call it model, on your right? So what you would do, you would introduce a black box, right? You will send all the features over here. It will do something. It will do what? It will scale them and then it will return the equalized sort of features to the model, and then model will be able to learn in a better way. So we have two types of feature scalars. One is min-max scalar and second is standard scalar. By the way, it's just name is standard. It doesn't mean that it is a standard. It's just name is standard. So these are the scalars that we use in normally in machine learning. There might be some others, but these are the most famous scalars. Okay, so in min-max scalar, we scale all the features from 0 to 1, right? Perfect. And in standard scalar, we scale our features in a normal distribution form, which means it comes in a bell curve sort of thing. So it scales it in a way that most of the features come near the mean position, and mean is 0 in standard scalar. So not going into very deep maths, but these are the formulae that we will be using in Python. So x is your data point, x min is the minimum value in the column, and x max is the maximum value in the column. So it will scale the feature going in very negative direction, right, to close to 0, and the feature going in very positive direction, right, let's call it positive, let's call it negative. So the feature that will go in very positive direction, it will scale it, it will convert it somewhere near 1, and vice versa. And same goes on standard scalar. By the way, in standard scalar, x is our data point, this is mu sign, this is for mean of the column, and this is for the standard deviation of the column, right? So let's go to the Jupyter notebook. Enough of theoretical explanation, and let's implement it. Oh, where is my notebook? Here it is. So first thing first, let's import some libraries, and then let's read data. And we will read only 2 columns just for the sake of simplicity, and let's name those columns alcohol and malic acid. And then we are just displaying our data. So alcohol has these values and malic acid has these many values, right? And now let's just check the summary of these columns. So mean of alcohol is 13, whereas mean of malic acid is 2.3. So scale is obviously different. Another thing, minimum value of alcohol is greater than the maximum value of malic acid. So we have to scale, we can do 2 things. We can scale up malic acid or we can scale down alcohol. So, or the third thing is we can use min max or standard scalars that we have just discussed to, equalize the amount of these features. So let's just visualize the data first. And by the way, I'm just using matplotlib to visualize the alcohol and malic acid feature. If you don't understand how we use this visualizations, we have a complete course on data analysis and data visualization. Please check it out in the description. So we're setting column, X label, Y label, legend, and just we are setting some grids and we are showing it. On X-axis, the important thing is on X-axis we have alcohol and on Y-axis we have malic acid. So let's discuss it in PowerPoint so that we can annotate it. Right, so you can see that the values of alcohol goes from 11 to 15, and the values of malic acid goes from 0 point something to up to 5 point something, right? So the scales are quite different. So we have to scale it so that in min-max scalar, everything becomes under, from 0 to 1, or in standard scalar, everything comes in sort of this bell curve. So let's go to the Jupyter and let's implement it. By the way, you can find this code in the link of this code in description. Don't worry about it. So first of all, we are doing it using standard scalar, right? So std scale, just a variable name, and pre-processing, we have imported it from sklearn, right? And we are instantiating an object of standard scalar, right? And then we are calling a method fit. It will fit on alcohol and malic acid, right? We have 2 columns. Then we are transforming these features, right? This, using this object, we are just transforming these features and using the storing the result in this variable. By the way, this is the sklearns implementation of standard scaler. Python implementation is also coming in a minute. So here, let's run it. And now let's run this one. So here I'm just displaying some data which shows that mean after standard deviation is 0 of both, right? And standard deviation after standardization, it is also called standardization, is standard deviation is 1 for both. Previously, if we look over here, mean was 13 and 2 respectively. Now you can see that mean of both the values, both of the features is exactly same, and standard deviation is also same. Later on we will also visualize this data as well. Now let's talk about min-max scaler. So here it is. Again, the process is same as it was previously done. So we are instantiating an object of min-max scaler. It is also coming from pre-processing, and pre-processing is coming from sklearn. And then we are just fitting it over here, and then we are just transforming our features, right? And let's run it. And then let's display the results of min-max scaler as well. Here you can see that minimum value for alcohol is 0, and minimum value for malic acid is also 0. On the other hand, maximum values for both the variables are 1. As we discussed, it scales the data from 0 to 1, between 0 and 1. Now let's visualize our data. Again, I'm using this matplotlib for this one. So this will plot the original data, right? It will plot a scatter plot, right? And then this will plot a data after standard scaler, and this will plot the data after min-max scaler implementation, right? And then we are just setting some title and labels. Let's run it, and here it is. Here you can see the result of what we have done. Let's discuss it in presentation. So previously we had this data. As you can see that maroon is color of original data input scale, and then standardized data is in red, and then min-max scaled is in gray or black. So original data is somewhere over here, you can see that, and it is much distributed. Now if we talk about, let's first talk about min-max scaled. You can see that whole data is distributed between 0 and 1 for both, right? For malic acid as well, and for alcohol as well. On alcohol you can see that this is 0, and probably here it will be 1, and if we draw it you can see that it is from 0 to 1, and in alcohol also it is from 0 to 1. Awesome. So let me just remove it. So now talking about standard scaler, I told you that it makes a normal distribution, which means it makes sort of a bell curve, right? It is not exactly the bell curve because I have some beautiful, drawing skills. So it basically makes a bell curve. Now we are talking about these red dots. So it has made a bell curve for both malic acid and alcohol features, and its mean is 0. You can see that this curve is around 0 and its standard deviation is 1. So that's how you can see that before and previous comparison. And here also we have this this previous or before data, and now this is before data, and now this is after data. And in after data we have two sort of data, one for min-max and the other one for standard scaler. Now let's learn how can we implement it using Python. It is very easy. So far we have learned it, we have done it by using sklearns implementation, and now let's do it by using simple Python. By the way, if you can manually check the mean or maximum or minimum values, you can do that. So in simple Python, let's say we have this X feature, right? I'm just giving you a demo. So this is X feature. First of all, while calculating standard scaler, it is also called z-scores, right? So first of all we have to have mean, and then we have to have standard deviation. If we go back and we check its formulae, you can see that in standard scalar we have to have mean and standard deviation. So that's how we calculate mean, sum over length, and then that's how we calculate a standard deviation. It's just a mathematical formula, and we have to calculate it by iterating over all the points, right? You can check the formula anywhere. And then that's how we calculate the z-score. We have to subtract mean from every point, and then we have to divide it by standard deviation. And that's what we are doing. We are iterating over every point, and we are subtracting mean from point and then dividing the difference with standard deviation, and it is giving us a list that is z-score, or that is standard scalar. Min-max scaling implementation is quite easy. We have to subtract minimum value from the point and then dividing it by the difference of maximum and minimum value of the column. So that's how you can do it. This is your data point, this is the minimum value of column, and then this is the maximum value of the column, and again minimum value of the column. That's how you exactly implement that mathematical formula, and you're obviously iterating over the loop. And we are using, by the way, those who are not very comfortable with Python, we are using list comprehension over here. If you have any issue with your Python skills, we also have a Python course on our channel, you can check it out. So let's run it, and let's just display z-scores and min-max. Let me just add some text before it so that we can recognize. So this is standard scalar, right? And we also have we should add some next line. I think that's how we add it, right? Awesome. So then we should add a value over here as well. So not value, but some description. So what it is min max scalar, right? And then next line, comma over here. Perfect. So you can see that in min max scalar, minimum value is 0 and maximum value is 1. And another interesting thing is, you can see the maximum value 1 is for those numbers who are maximum in original feature set, and minimum value 0 is for those features who are minimum in the feature set, right? And same goes out for the standard scalar. Minimum value would be for those, because it is basically, it is not changing your feature, it is transforming your feature, right? So let's do it using NumPy as well. Using NumPy it's quite easy. Let's just generate an array, and then you can calculate z-scores quickly by doing this one. That's your feature point, and you don't have to iterate over it because NumPy does it for you. And then we are subtracting it from mean, and we are dividing it with standard deviation. NumPy has built-in implementation of standard deviation, exactly what we have done somewhere over here. Yeah, exactly, right? And same goes out for the min-max scaling. We are subtracting minimum number from every point, and then we are dividing it with the difference of maximum and minimum. Let's run it. Here you can see the values for the both of the implementations are exactly same. You can see, right? You can compare it. The only difference you might be getting is this is 1.0 and this is 1.0 is not available because NumPy doesn't display 0 if 0 is coming, after the point. So 1 point is exactly 1.0. So that's about the feature scaling thing. You should scale the feature before going into any machine learning algorithm. One more question that you might be having in your mind, that which one we should be using. Should we use min-max scalar or should we use standard scalar? Which one is better, right? So the answer is there is no theoretical justification for min-max scalar or standard scalar betterment. Both are better in some, one of these is better in some cases and the other one is better in the other cases. So what you should do is you should implement both, right? And then you should see which one is giving you minimum error or which one is giving you maximum accuracy. So this is sort of an engineering thing, right? There is no theoretical justification right now available anywhere. Some algorithms work fine with min-max scalar. Some algorithms works fine with standard scalar. Moreover, some data sets works fine with min-max and vice versa. So that's about it. Do support our channel, and this is our website link where you can find a lot of courses that are especially made for the beginners if you want to start your career in data science. Do subscribe the channel and hit the bell icon. Thank you.